All right. Good morning. Good morning, everybody. We are going to start with a quiz, as I promised. I said that I really wanted to make sure that we were all getting this factoring down. So if you could take out a sheet of paper, put your name on it, put the date on it. That's all you need is your name and your date and the date. It is the 25th of March. Name, date. And if you don't mind, just in case the wind blows and I lose all my papers, just put 9:30 a.m. somewhere there. That way I know what class this is if I mix you up with one of my other classes. What's that? If your quiz is an A, don't lose it, but if it's a C, lose it. Okay. All right, so everyone ready? Just I want you to do your own work because I want to see what you can do. All right? The 25th. Today is the 25th. 3/25/14. All right, so I'm going to give you two problems, all right? And both of these are to factor. So factor, let's go with 4x cubed minus 3x squared minus 12x plus 9. And the second one, again, factor 9x squared minus y squared. And I'll give you a hint. The first one is going to require grouping because you have 4 terms. The second one is a special case that we did at the end of class last time when you have 2 terms, something like that. So, okay. On your test, I would allow you to have a formula sheet. So at this point, this is the only formula that you would really use. Oh, I meant to tell you I might get a call. Looks like I'm getting that call. Okay, go ahead. recording here. So let's talk about this quiz. Remember, I'm promising you a quiz just like this every day for the next few classes until we get out of this factoring thing, because we've got to get this stuff down. In fact, I might even give you another quiz at the end of class too. I mean, it's really important that you understand this and that you can do it without your notes, without your book, without your homework. Just, you know. Okay, so let me go through these. I'll get back to that formula here in just a second and move that down. Okay, so on this first one, I gave you the hint that we were supposed to use grouping here. Now, without that hint, what would have told you that is the fact that you have 4 terms. And we said whenever we have 4 terms, you try to do grouping. So what we did was we would kind of split these 4 terms up right after the second term, before the sign here. And then in the first 2 terms, we would try and see if we can find a GCF. In this case, the only thing we have is x squared. So we factor out an x squared. We are left with what? 4x minus 3. And then I think what most of you liked was when I would just take that and put it over here, right? Did we talk about that enough? Okay. So we're trying to match it over here. And now we look at this side and we say, okay, I want this to be what factors out, or I want to factor something out which leaves this. So can I turn the 4x into the negative 12x, and can I turn negative 3 into positive 9? Well, if I multiply 4x by negative 3, I get negative 12x, right? So I put a negative 3 out here. And then I just double check, is negative 3 times negative 3 9? And yes, it is. So once these 2 things match, you put the 4x minus 3 in parentheses, and then you put the 2 factors that are out front in their own set of parentheses, right next to it. Now, technically, we would want to continue to look at this, because this is almost, I didn't want to be that mean to you, but this is almost a what? It's almost a difference of squares. If it was, we would have to break that down. But I didn't do that. So if that had been a 9, you could have actually gone another step on this. But we'll address something like that more today and as we move on. So this is it right here. This is what I would have been looking for on that one. Okay, now on the next one, that is exactly a difference of squares problem. So difference of squares formula said that if we have something squared minus something squared, that equals a plus b times a minus b, right? The important thing to recognize is that our a, that squared here, right? That squared is on the entire a. So you could put almost like a set of parentheses around this and around the b. So you have to have something, and the entire thing has to be squared for you to be able to call that a. So when we look at this, what is that squared acting on? Is it acting on the x or the 9 or both the x and the 9? Just the x, right? In the formula, see, I don't like the way the book writes it because they don't put parentheses. So you don't really get that idea that whatever's here, whatever you're going to call a, the entire thing has to have the squared on it. So since the 9 does not have the squared on it, I need to rewrite this as something squared. Now, the x squared I can get by putting an x here, right? But to get 9, I need to square the number 3, don't I? So I need to put a 3 here. So it has to be 3x. You square that entire thing. 3x times 3x is 9x squared. Okay? And then on the other one wasn't as tricky. It's just y, right? Because that squared is acting on the y, and there's nothing else there with it. So I could, in parentheses, put the y like that. And that makes my a, right? My a is the 3x, and my b is what? Y. So my b is like the y here. So I just follow this formula now. So this should become a plus b, so 3x plus y, and then 3x minus y. Yes? What do you mean? Like out here there was a negative in front? Then you could not do this. Because in order to use difference of squares, it has to be a positive term, take away a term, right? So, or subtract a term. So if these were both negatives, difference of squares would not work. Good question. All right. We're going to continue with this today because we still have two other formulas for when we have two terms. All right. All we've seen up to this point is the difference of squares formula. And I'm gonna do maybe one or two more examples of difference of squares, and then we'll move on to the other two formulas. So how about this? How about 18x squared y squared minus 50x squared, 50x squared. There we go. Now, on the quiz that I just went over, I forgot to mention something. The very first step of factoring, right, is what? GCF, right? I mean, once you've identified how many terms there are, and in this case we have two terms, right? But we always want to look for GCF. So do you have a GCF in this problem? Okay, let's look at the numbers. Is there a number that goes into both 18 and 50? They're both even, right? They're both even numbers. So at least 2 goes into them. Does 3? Well, 3 doesn't go into 50. 4? No. 5 doesn't go into 18, but it goes into 50. So 6 goes into 18. 6 doesn't go into 50. So you could go through this. 2 is going to be the greatest common factor. So 2. And then you have x squared also, right? Because they both had exactly x squared in each one. Then in parentheses, we have enough space there for how many terms? 2. And now what we need to do is somehow turn a 2x squared into an 18x squared y squared. So 2 turns into 18 if we multiply by what? 9. X squared turns into x squared if I just don't do anything, right? And then I need to produce a y squared, so I put y squared, right? Because I didn't have any y's over here in my GCF. Anything else on that one? No? How do I turn 2 into negative 50? Multiply by negative 25, right? How do I turn x squared into x squared? Well, I don't. It already is, right? So that's it. That's just GCF, though. Look inside that parentheses, and what do you see in the parentheses? A difference, right? It's 2 terms. There's a difference between 2 things, and I noticed that 9 is a perfect square, right? It's 3 squared, and 25 is a perfect square, 5 squared. So if I can get it to look like a squared minus b squared, then I can apply that formula. So how can I take 9y squared? I'm doing this on the side here, okay? This is like separate work. How can I rewrite this? 3y plus 5. Now, I need some parentheses here, right? 3y squared and then 5 squared. Technically, I do not need the parentheses on the 5, because 5 squared is 5 squared. I have to have parentheses on this, right? There is a major difference between these two, right? Here, the squared is only on the y, so you'll never get the 9 out of this. Here, the square goes to the 3 and the 9, so you would get, the 2 goes, the squared goes to the 3 and the y, which means you get the 9 and then the y squared. Y'all see the difference? Okay. So that means that our a in the problem, right, is 3y, and our b in the problem is 5. So following the formula, it should be 2 sets of parentheses, a plus b, a minus b. And we still have that 2x squared outside. So I'm going to write 2x squared out here, 2 sets of parentheses, 3y plus 5, 3y minus 5. That's it. You could put the 3y minus 5, 3y plus 5. Yes, you can change that. Doesn't matter. Any questions on that? Okay, let's look at another example. How about negative 81 plus 4x squared? This problem is just intended to try and trick you, just kind of confuse you. All right? Listen. This looks like you have two terms, right? You don't have a GCF here. So the only thing we know up to this point is that if we have two terms and we've pulled GCF out, we can just look at those two terms and ask ourselves, is it a difference of two squares? Well, you might be thinking no because there's a plus sign between them, right? But if you reverse the order of this problem and put your 4x squared first, then it becomes minus 81, doesn't it? Because your 4x squared is positive, so you put it here, and then negative 81 is minus, or negative, so that's the same as subtracting it. So these are exactly the same problems, aren't they? Yeah, it's a commutative property of addition. You just flip it. Now it looks like a difference of squares, doesn't it? I can rewrite 4x squared as something squared, and I can rewrite 81 as something squared. What are they? 2x and 9. So our a here is 2x. Our b here is 9, isn't it? So 2x plus 9, 2x minus 9. So there's our 2x, 9 right there. All right. Yeah, good question. Well, you would look at each of these and you would say, okay, I have two terms. Does it look like, well, the only thing we know for two terms right now is difference of squares. So that's not a difference of squares. This is not a difference of squares because even though 9 is, right, 2x, 2 is not a perfect square. And the x doesn't have a squared on it either. It's done. One last one with difference of squares. This one, this is like a classic problem, and you won't like it. X to the 8th minus 1. All right, do we have a GCF? No, right? Can't take anything out of both. Do we have, well, we have two terms, right? Does it look like a difference of squares? Well, we have subtraction, right, between them. And this one's positive, so, I mean, it does look like something minus something, right? But is it something squared? No, I mean, x to the 8th is not something squared necessarily, right, when you just look at it. 1, how about 1? Is 1 a perfect square? Isn't 1 squared? Yes? 1 is 1 squared, isn't it? So watch this. Do you agree that I could rewrite that first one, x to the 8th, as x to the 4th squared? I could, right? Because the property of exponent says that if you have something to a power, you multiply the powers. 4 times 2 is 8. So isn't that right? And then I could say minus, and now I could rewrite 1 as 1 squared, couldn't I? 1 squared is 1. So that's the exact same problem. I have created an A, and I've created a B, haven't I? So according to the formula, this should be A plus B times A minus B, right? So, wow, come on, chill out over here. What's A plus B? X to the 4th plus 1, x to the 4th minus 1. Yes. Yes. Wait. 1x squared. I don't see. Oh, this one right here. No, no, no. The reason I do that is because I'm trying to apply this formula. This formula says basically that if you have something like this, two things being subtracted and each one of them are squared, in other words, you can rewrite them as something squared minus something squared. If you can do that, if you could somehow massage the problem to make it look like that, then you can now turn this into this right here. So I'm not doing something on both sides of the equation. I'm just trying to force what I started with to look like this. Does that make more sense? This number would have had to have been a perfect square, though. It would have had to have been like 1, 4, 9, 16, 25. Like if it was 3, then what squared is 3? See, 1 squared is 1, but right here, look at this one. 9 squared is what? No, 9 squared. 9 squared is 81, right? So when I started with 81 here, I had to think, how can I get 81 by squaring something? Well, I have to square 9. But if that, again, if that would have been a 3 there, I can't think of a number that I square to get 3, because 3 is not a perfect square. Okay? We're not done. How many terms here? Is this a difference of 2 squares? Do you see subtraction? No, right? So this is not a difference of squares. This one is. Because just how I rewrote, remember x to the 8th, I wrote as x to the 4th squared because I was being clever. How can you rewrite x to the 4th as something squared? As x squared squared. X squared squared. So I think I'll do this on the side. I'm just going to look at this right here. X to the 4th minus 1 is the same as x squared squared minus what squared? 1 again. See how I did that? I'm looking at this. I'm saying, this looks like it might be a difference of squares. If I can rewrite x to the 4th as something squared. What if that was x to the 5th? You couldn't do it because you can't. This has to be a 2 out here, right? This has to be a 2. I can't put anything here that when I multiply by 2, I would get a 5. It has to be a nice integer. So x squared squared is x to the 4th. So what's a in this one? And b is 1. So that breaks down, according to the formula in red, to be a plus b times a minus b. So x squared plus 1 times x squared minus 1. Y'all see it? So that right there is just this. So I'm going to rewrite the problem again. I'm going to put my equals out here. I have x to the 4th plus 1. That was the first part I had. And then the part that's circled here broke down to be 2 more things, didn't it? It was x squared plus 1 times x squared minus 1. You see it? Yes. The only way this is ever going to work for us, like on, if I give you a problem like this or something, the only way it's ever going to work, difference of squares will work, is if this is squared, 4th power, okay, or 6th power, 8th power, or 10th power. It has to be an even number. If I give you an odd number, you won't be able to use the difference of squares on it. All right, box it up. I'm asking you, box it up? No. Because look, we already said this is not a difference of squares. This is now not a difference of squares, but this is. You see? We have difference, we have 2 things, each one of them can be looked at as being something squared. So I can actually take x squared minus 1 and break it down to be, I'm going to kind of run out of room here, but I'm taking x squared minus 1, right? I'm breaking it down to be something squared minus something squared. What do I have to square to get x squared? Just x, right? Right? X squared is x squared. And then what do I have to square to get 1? 1. So our A here is what? X. Our B is 1. So it becomes now x plus 1 times x minus 1. So we get x to the 4th plus 1, x squared plus 1, and then that last factor, this one right here, broke down to be x plus 1 times x minus 1. This is the type of problem that I would give to make sure you understand difference of squares, right? Right? I mean, this test to see that you can apply it over and over. Questions? Yes? This right here? No, watch. This became these two, didn't it? Right? And then this was this, and this was this, right? And if you want to look back above, this piece here was that, right? And this piece here became these two, didn't it? Because your difference of squares splits into two things, right? So that x squared minus 1 at the end split to two things, but these two still stayed. You like bonus problems, right? Everyone's always asking, what can I do to kind of bump my grade up a little bit? I'll give you a bonus problem, all right? I have to think about this, though. How about this? Now, this will be, you just turn this in next class, okay? I don't want you to work on it right now. We'll go x to the 8th again, minus, hold on a second. I really got to make sure that I get this. 2 squared, 4 squared, 16. 9. 6, 1, 6, 1, oh, is that right? 150. Oh, 256. I don't know why I wrote 156. Yeah. Thank you. You're watching my arithmetic there. I was like, that just doesn't seem right. I should be ashamed of myself. I kind of am. Okay. So let's make that just a take home. You know, turn that in next time if you want. Completely factor that. It's very similar to what we just did, except you know how we had the 1 the whole time? Like 1 squared was 1, 1 squared was 1. It's not, you're not going to have the 1, but it'll be nice. Okay, that's a bonus problem. Turn in beginning of class next time. All right, now let's talk a little bit about a different formula. What we've seen so far is that with two terms, right, with two terms, if we have a squared minus b squared, which meant that we had something squared minus something else squared, like that. And I'm using the parentheses to stress that the squared has to apply to both, or whatever's in the parentheses, that turns into a plus b times a minus b. And this is called difference of squares. I took the if out of there, okay. That's what we know. Something squared minus, which is where the word difference comes from, difference. If you have the difference of two squares, then that's the breakdown of it. The question now becomes, what happens if you have this? This would not be called the difference of squares. This would be called the sum of squares. The question becomes, is there a formula that will allow you to break it down like this? Because that's basically factoring. That's what we've done. We've taken two things being subtracted, we turn it into multiplication. So if you have a sum in between them instead of a minus, is there a formula for it? And it turns out there is not. Okay? Yes. If we have two things being squared in a minus between them, it is a difference, right? Difference meaning subtraction. If we have subtraction between two squares, it will break down. It'll break down to be this. But if that minus is replaced with a plus, it's no longer a difference, it is a sum of squares. And we ask ourselves, is there a formula that will allow us to factor it? The answer is no. Okay, so what we say is, this is prime, which means not factorable. Prime is what I would like for you to put on a test or a quiz. Prime. Okay, can't do it. Cannot factor it. So as an example, if I put 4x squared plus 9, first thing you do is you look at it, you say GCF. No GCF, right? You say two terms. I have two terms. What are the things I have? Difference of squares, right? And sum of squares. It could be one of those two things right now, right? Which one is it? It looks like a sum, right? Because I have something squared plus something squared. But because it's a sum of squares, I know it does not factor. So at this point, it's over. And I just write prime. And I'm done. I bet you'd want me to put like 10 of those on the test and just call it a test, right? I have two questions. Yes? With that plus sign that I had in there? Yes. That is exactly why on these problems I did not try and break these down, because these are pluses, and the formula does not apply if you have a plus. Okay? Yeah, these break down because these are a difference. I'm glad you brought that up. That's a very good point. Okay? Yeah, why didn't I mess with this one? Well, because it doesn't follow the formula, right? It has to have subtraction. But now I'm telling you the reason why you can't mess with that is, I mean, maybe there was a formula, I just didn't show it to you yet, you know? But what could we break down? We could break this one down, right? Because we had the formula for those. It was still kind of a question. Yes. That's because both of those are prime. That's right. They don't break down. Yes. I'll have to look at, I don't recall. I don't think any of them were prime, right? Maybe at the end we can take a look at it? Okay. What if you had 20, where? Oh, if I had a GCF, I would have pulled that out, right? And then at that point, I would have said prime. Like I can't go, prime means basically I can't go any further than I am right now. So yeah, GCF is always something we would take out in the beginning. So we would be done here, right? Now, what about this? I'll put it right below it. Yeah, see, this one you can switch it, right? You can change the order. So the thing is, I don't want you to look at this and be like, okay, the thing I need to look for is a plus sign. If I see a plus sign, it's prime. That's not the case. Here, the plus sign, yes, it's making you think it might be prime, but because that's a minus, you could put it on the other side of the 9, like this, and now you do have a difference of 2 squares. And that would be 3 plus 2x, 3 minus 2x. Right? A is 3, B is 2x. Break it down. So just make sure you're careful with that. How about this one? How about negative 4x squared minus 9? What's your first step? GCF? Is there a common factor? Not really. You could say negative 1, couldn't you? You could. But right now, is this a difference of squares? The problem is the negative out here, okay? The negative. How can you ever write, I mean, just look, if you try it, you need to write something here that when I square it, you get negative 4x. But you can't square anything and get negative 4, can you? Because anytime you square something, it becomes positive.
What about if you have your sign square?
Where? Up here at the 2?
No, down.
In front of the x? Well, then it would, I think you're saying, are you saying like this? Or no, just take the 4 out?
No, I was saying about, for example, putting parentheses.
Mm-hmm.
And then minus square.
Minus 2x.
I mean,
Oh.
minus outside.
Oh, like this. Okay, what's wrong? Yeah, what do y'all think about that? What's 2x squared? 4x squared, right? And then a minus out front, okay? And so that would make it negative 4x squared. And this right here, 3 squared would be 9. But what's wrong with that? Does this look like a squared minus, yeah, does that look like a squared minus b squared? No, it looks like negative a squared minus b squared, right? Because you have an extra negative out here. So this is not the formula. The formula only works if it's a positive term, take away a term. These are great questions. These are all the little subtleties of algebra that make algebra hard, is truly understanding how all these signs work together and how can you have that out there? Does that work that way? Once you kind of get your head around all of that, algebra becomes a little bit easier. But it takes a while to get comfortable with it. So good question. But do you see why it doesn't, that negative right there will not match the formula? Okay. All right, but what would we do with this? Is this a difference of squares? Do I have a positive thing minus something? No. Is it a sum of squares? No, not really, right? There's no plus. But just watch this. This isn't going to be crazy. I'm going to factor a negative 1 out as a GCF. What would I get if I factor a negative 1 out? I get 4x squared plus 9, wouldn't I? That just goes to show me, to prove to me that that was prime. Because look at this. 4x squared plus 9 is a sum of squares. And you cannot factor that. So the most you could ever do here was take the negative 1 out. But even then, you know, you can't go anywhere with that. So I've given you kind of like almost every case. This is the case it's prime, right? Where they're both positive and there's a plus between them. This one is tricky because there's a plus, but this is actually a difference of squares. This one, they're both negative. If they're both negative, you can really look at it as a negative 1 coming out, and now they're being added, so it's prime. If you knew right here it was prime, I'd be okay with that. If you did this to kind of just double check yourself, that's fine also. What I wouldn't want you to do is something like this. You know, negative 2x squared minus 3 squared. That's not correct, right? You square negative 2 and you get positive 4. You don't get negative 4. Okay, So sum of squares is kind of like our good case, right? That's the nice one. There are two more formulas that involve cubes instead of squares. All right, so here they come. The first one we'll do is, what if we have a cubed, let's see, I'll do sum first, plus b cubed. Now this is the same as something cubed plus something cubed again. So I'm using those parentheses again to kind of stress to you that whatever it is, whatever you're going to call a, the whole thing cubed has to be that first term. And then same thing with b. Now the question is, does this have a formula? The answer is yes. For cubes, it does. All right? I'm not real big on memorizing things, but yeah. But this one is one I have memorized. I'm not going to expect you to have it memorized. You'd be able to put this on your cheat sheet. The formula is, it's going to be 2 terms multiplied times 3 terms. So it's going to be a binomial times a trinomial. You know how difference of squares turned out to be a plus b, a minus b? So it's 2 binomials with, we call this a sum of cubes. Sum of cubes. With the sum of cubes, it is a binomial times a trinomial. And it is a plus b. Hey, that looks like difference of squares formula, right? And then it all goes to hell right here. A squared minus ab plus b squared. Best. All right? Like I said, you don't have to memorize that. But, you know, if you do, go for it, whatever. So let's see this applied, and we'll start with something, you know, kind of basic, and we'll work our way up. How about x to the third plus 1? GCF? No? How many terms? 2. What do we have in our bag of tricks with 2 terms? Difference of squares, sum of squares, which is prime, and now sum of cubes. Which does this look like? Sum of cubes, because there's a cube there, right? Now, the question is, can you rewrite 1 as something cubed? Well, 1 is 1 cubed, isn't it? 1 times 1 times 1 is still 1. So I'm going to try and force this to look like something cubed plus something cubed. What would be in my first one here? X is x cubed. X cubed is x cubed. And then 1 cubed is 1, right? So that'll work. So what is A? X. And B is 1. So there's our A, there's our B. And now all we do is we apply the formula, right? So there's no work. We're not working on both sides of the equation or anything like that. We've identified what A and B is, and now we just plug in and we just rewrite this up here, replacing all our A's and B's with whatever we said A and B was. All right, so here we go. What is A? X. Plus, what is B? 1. Now, what is A squared? So that's X, but squared, right? Minus, now look at this middle one, A times B, AB. So I do X times 1. X times 1 is 1X, or just X, right? So I put X here. And then finally, plus B squared. That's plus 1 squared, which is 1. And that's it. Questions?
On the X, on the negative X, you can still put in the 1, right?
You could put in the 1. You see where all those pieces come from? Yes, you can still put in the 1. Just make sure you put that negative sign in here. Now, next class, we are going to talk about factoring three terms. And that's what we have in here, right? Right now, we haven't even looked at three terms. We've looked at four and we've looked at two. To do three terms, there's a whole technique for it. But let me tell you this. When you use a sum of cubes formula, this three-term polynomial will never factor. In other words, you will not have to look at that and try and break it down. This is factored. This now is prime. This piece right here is prime. Cannot go any further. All right? I'll address this again once we start doing three terms. Because what we'll have at the end is problems where there's a mixture of different types of factoring in it, and we'll address it more then. But I will need to look at this right now and just make sure I've got two terms, nothing factors there, right? I'm good? Yes. I don't know. What is what together? Mm-hmm. Well, we haven't looked at a cubed minus b cubed. So we have a sum of cubes formula and a difference of cubes formula. For squares, difference of squares, do we have a formula? Yes. Sum of squares? No. Sum of cubes? Yes. Difference of cubes? It's going to turn out to be yes, but I'm not ready to give you that yet. Well, I'll give it to you today, though. I don't want you to leave here shorthanded, you know? You deserve the difference of cubes formula also. How about this one? 8m cubed plus 27. Yeah, let's do 27. GCF? Number that goes into these? 2 and 4, 2, 4, and 8 are the only numbers that go into 8. But 2, 4, and 8 do not go into 27. So we can't pull a GCF. Two terms. It's not a difference of squares, right? It is not a sum of squares. Well, is it a sum of squares? Well, no, the cubed is kind of giving it away, isn't it? And the fact that 8's not a square, 8's actually what number cubed? 2 times 2 times 2. And 27's not a perfect square, but 27 is 3 times 3 times 3. So it might be worth it for you to just maybe recall what the perfect squares and perfect cubes are, because that'll help you in these problems identifying these things. But let's try and break this down. Can we rewrite it as something cubed plus something cubed? So how can I get an 8? By cubing what? 2. How do I get m cubed? By cubing m. So if you take 2m times 2m times 2m, you should get 8m cubed. And then how do I get 27? I cube 3. Be careful, because we're cubing it, not squaring it. We're not multiplying. No, sorry, we're not multiplying by 3. We're saying something times itself 3 times should give us 27. 3 times 3 times 3. Now we can use the formula. We're going to use our a is 2m, right? And our b is 3. Now you have to be extremely careful with this, all right? Right? You know, the first problem worked out pretty clean, didn't it? This one is a little bit tricky. I have a binomial and a trinomial. Right? The first part of this is just what? A plus b. So a is 2m plus 3. So 2m plus 3. So there's nothing fancy happening there. Here's where it gets a little bit weird. What's the first term of this trinomial? A squared, right? What's a for us? 2m. What's 2m squared? What's 2m? I'm doing it on the side here. What's 2m squared? Square the 2. What's 2 squared? 4. What's m squared? M squared. So this should be 4m squared. 4m squared. Yes. Yes. What I'm going to do first, I'm going to write right above this what the formula is?
Oh, okay, I got it.
Right? That's the formula. So I have to take whatever my A was and square it and put it here. Well, 2m squared is 2m times 2m, which is 2 times 2 times m, which is 4m squared. You see, so the squared is on the m, but it's not on the 4. You see that? That's where things can get a little tricky. It would be incorrect here if you put 2m squared. That'd be incorrect. Because you squared the m, but you didn't square the 2. All right, next piece, I'm going to have a minus. And now I have a times b. 2m times 3. What's 2m times 3? 6m. And finally, plus b squared. B is 3. 3 squared is 9. You see how that's a little trickier with something more complicated? It's really the parts that are really you have to be careful with is this first one, this last one. You have to make sure that you square them properly. All right. I think another one is in order here. Hey, let's list out real quick. What are the perfect squares? Let's just list out the first few perfect squares, and then we'll list out the first perfect cubes. Okay, perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144. Right? Yes. Well, they are what you get. Those are the numbers you get when you start squaring 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're perfect squares because they come from you squaring a nice integer number. Like not even this one right here. 1 squared is this, right? 2 squared is this. 3 squared is this. 4 squared. So they're the perfect squares because if I kept on going in this list, I create a list of numbers, right? And we call them the perfect squares. The perfect cubes are 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, and then you keep going, right? So what's 1 cubed? 1. 2 cubed, 8, 3 cubed, 27, 4 cubed. 4 times 4 is 16 times 4 is 64. 5 cubed, 125. And then you start going, at this point, like from this number on, you start getting into like math dork territory. You know, like who knows the perfect cubes after like 5? Well, you start getting into math dork area here. Same with like these squares, for perfect squares. Like after 144, if you know the perfect squares after 144, that means you're doing more math than normal people do. Same thing with perfect cubes. After about 125, they're not things you see a lot. But how could you figure out what the next one was? Just get on your calculator, do 6 times 6 times 6, right? 7 times 7 times 7. 8 times 8 times 8. 9 times 9 times 9. Let me go back to the next example I wanted to give you. How about 40 x cubed y cubed plus 5, 5. What do we do here? GCF, good. If you don't get that GCF to start the problem, you're going to be lost. You've got to get that GCF out first. What is the GCF? 5. 5 comes out, leave space for 2 terms. What do you have left? 8 x cubed y cubed plus 1. Inside this parentheses, you have 2 terms, right? So it's either difference of squares, sum of squares, which is prime. Is it sum of squares? No. Too bad. Or sum of cubes, which we have formula for. So does this look like sum of cubes? Yes, the cubes kind of give it away, right? But also 8's a perfect cube, and 1 is a perfect cube. So can you rewrite that? Okay, the question is, can you rewrite this right here? I'll just do it on the side here, as something cubed plus something cubed. So how do you get 8? 2 cubed. How do you get x cubed? X. And then how do you get y cubed? Y. And then how do you get 1 cubed on the other one? 1. So there's your A, there's your B. So A is 2xy, B is 1. So I'm now going to apply this formula. So 5, I'm going to have a binomial followed by a trinomial. It'll be A plus B, A squared minus AB plus B squared. What's A plus B? Two xy plus 1. Do I need to stop? Am I going okay here? Okay, now what's A squared? Let's square that. So square the 2, that's 4. Square x, square y, it's x squared, y squared. So our A squared should be 4x squared, y squared. 4x squared, y squared minus, what's A times B? 2xy times 1 is just 2xy, right? And then plus, what's B squared? 1 squared is 1. That's it. That's your answer. Now, we only have 7 minutes left, but I want to give you the next formula, because the next formula is very similar to this formula. You apply it the exact same way. So let me show it to you. This will be our last formula for 2 terms. If you have A cubed minus B cubed, we call this the difference of cubes. And again, you'll be looking for something cubed, take away something cubed. This will be equal to a binomial and a trinomial. So it's going to be exactly the same format, binomial, trinomial. In sum of cubes, the first thing we had was A plus B, right? Here we have A minus B instead. So I will just maybe highlight the differences, okay? The minus instead of the plus from the previous formula. Then in the other formula, we had A squared, right? Then we had minus AB, right? It's actually now going to be plus AB. So that changed. So it looks like just all the signs are changing, right? What did we have in the previous formula as our last term? Plus B squared? Well, here it's going to be plus B squared. Shit, it doesn't change. So that's the only exception for this, is that the plus B squared actually stays plus B squared. Okay, so that doesn't change. So it's just the first 2 signs change. The formula is exactly the same, except for the first 2 signs are opposite. Now, how are you going to remember for the sum of cubes, your first one's plus, and for the difference of cubes, your first one's minus? Well, right? Difference has minus, so you start with minus. Sum has plus, so you start with plus. And then you switch the next sign, and this last one's always plus. However you want to remember, or just put it on your formula sheet. Just make sure you copy it correctly. The way I have it memorized is exactly the way I told you. I remember if it's plus, right? If this is a minus, my first one's minus, this one switches, that one stays the same. As far as everything else, I have all that memorized, like hardwired, you know? A something, binomial, trinomial. The pattern's all just kind of a picture in my mind. All right. So let's do a problem very similar to what we did to start off the other one. We did x cubed plus 1 a second ago, didn't we? So x cubed minus 1, the only difference here is the signs in our final answer. But I will go through, I will say, well, this is x cubed minus this is 1 cubed. So a is x and b is 1. So we have x what? Minus 1, parentheses, square the a, so square x squared, plus x times 1 or 1x or just x, and then plus 1. Good. That's it. If you look back at what we did a second ago when we did x cubed plus 1, it'll be x plus 1, x squared minus x plus 1. One more. Yeah. 16 minus 16 minus, sorry, I'm just thinking here about how I want this to be. 250 m cubed. So I try to make this a certain way that you would look at it and say, okay, if the difference is two terms. I see 16, I'm thinking 16 is 4 squared. But then you see a cube, so maybe you're confused now because you thought it was a square, now it's cube. But what did I forget to begin with? What's the first thing you always look for? GCF, right? If we GCF this, things are going to just fall right into place. What's a number that goes into both of these? Well, they're both even numbers, aren't they? If they're even numbers, they're both divisible by 2. So how many times does 2 go into 16? 8 times. How many times does 2 go into 250? So 125. So we have at least a 2, right? Which would give us 8 minus 125 m cubed. Do you agree? What is this now? Difference of cubes. Can I rewrite this as something cubed minus something cubed? Well, 8 is 2 cubed, right? And 125 is, off our little list of perfect cubes, was 5 cubed. And m cubed comes from m being cubed, right? So I've identified in this my a and my b. So here's where I am. Going from here, I have 2. Then I have a binomial and a trinomial. The binomial will be a minus b, right? So for us, that's 2 minus 5m. Man, I'm out of time. And then what? The next one is a squared, so 2 squared is 4. Then plus 10m, that's a times b, that's 2 times 5m is 10m. 10m plus, you've got to square b. Square the whole thing. 25m squared. Okay, who has a book that I can borrow real quick? I'm going to give you the homework assignment. I was going to say I would email it, but it'll be easier so you don't have to check your email necessarily. Let me give you something to look at from this. We're still in 6.2 here. I'm really taking my time through this. All right, let's look at page 412. Let's look at 29 through 45 odd. It's a lot of problems there. And then take a look at 47 through 65 odd. And I'm going to circle, I've given you quite the homework assignment here, okay? 47 through 65, the instructions say, use the general factoring strategy and factor completely. What that means is that on 47 through 65, they are not telling you whether or not it's a difference of squares, a difference of cubes, sum of cubes, or they're not telling you which one it is. You have to figure that out. With these, they're telling you it's either difference of cubes or sum of cubes. So they're kind of guiding you here. But all these problems, remember, GCF first, and then go try and use a formula. We'll have a quiz over this on Tuesday. Wait, what day is it today? Why do it feels like Thursday? Okay, this is a lot of homework then. See what you can do on this, all right? I mean, I know it's a lot, but it's important. Yeah, it's definitely doable. Everyone have a good day, even though I might have ruined it. Yes.